Hello everybody, I hope you have a good time. Today I want to solve another problem of static Meriam. It's about equilibrium, and here again I introduce my Telegram and WhatsApp phone number and also my ID on YouTube. You can subscribe my channel and now about my future videos. The problem that I'm gonna solve is number 53 of the chapter 3. To test the deflection of the uniform 200-pound beam, 200 pounds beam, the 120 pounds boy exerts a pull of 40 pounds on the rope rigged as shown. Compute the force supported by the pin at the hinge O. Here I have to draw the free body diagram of the beam with the guy, because if we draw the free diagram body of the beam only, we have to put the force under the feet of the guy and also the tension of the rope here, and in that situation the problem was a little bit harder than now, so I prefer to draw the free body diagram of the beam with the guy together. Okay, here we have to cut this rope from these two positions. Here I can put the tension of the rope T, because these 2 or 3 pulleys don't have a mass. Actually we assume that they are they don't have weight, so we can mention that the T is constant in each position of the rope. So, and here we have a roller support, so we have to put only one force in y direction, and we called it A of y. And here we have a connected support or joint support, and here we have, and it's a fixed support, so we have to mention not fixed, it's a joint support, and in this situation we have to mention O of y and O of x, but we don't have any bending moment here because it's a joint, and the beam is able to rotate easily over the joint O. So here we have only O of y and O of x, and also the 2 body forces act on this beam and guy. The first one is the weight of the guy, and it acts on the center of gravity of the guy. Here we have W of M, and also we have, and also another body force is the weight of the beam, and we called it W, and it acts on the middle of the beam because it's mentioned that the beam is uniform. We consider this distance 3 because this is 6, 3 feet, 3 feet, and 3 feet. Okay. And it's mentioned that the guy the tension is 40 pounds. Okay. You know, this beam with guy is a rigid body, and this problem is two-dimensional rigid body. And in this situation, we have three equilibrium equations. The first one is the summation of f of x is equal to 0. And the second one is, this is a positive direction, okay? And the second one is the f of y is equal to 0. This is a positive position, direction. And also the last one is the summation of bending moment, and this is the direction of rotation, positive rotation, is equal to 0. And we should consider this bending equation over a point here, because we want to find the force of O, so we consider the point as A here, because there is no need to find the force of A, so we mentioned A here, okay? And the summation of f of x, the only force that we have in x direction is O of x is equal to 0. And from this equation we can find that O of x is 0. And there is no need to find f of y, because we can find O of y from the third equation, so we write it here. O of y, the length of bending moment is here, so we can write O of y multiply 2 feet, and you can see that O of y is able to rotate the beam in this direction, and we consider it positive direction, okay? And the next one, you can see O of y, this is A. O of y, first of all, is equal to 0, and the second item is the length of finding the bending, the bending is equal to 0, so there is no need to consider it. And the third one is W, and we should mention this length multiply 3, and you can see that it can rotate the beam in positive direction, so we consider positive. And the next one is W of M multiply. We need to find this length, so we can write 6 plus 2 minus 4. And the next one, T, and the length is 6 feet. And the next one, another T, the length is 2 plus 6 is equal to 0. We should check all forces again. O of Y, W of M, T and T, and OX is 0. So 12 of Y is equal to, we have to find all of them, minus 3 multiply W is 120, excuse me, 200 pounds beam, 200 pound beam. So 200 plus 120 multiply 8 minus 4 means 4 plus, and the tension is 40 pound. 40. So you can see that all signs are negative. Minus 100, 1100. I think we have a mistake because we cannot find the answer. We should check it again. 12 of Y and I have a mistake. The answer was 1640, and if we divide it, okay, of Y is minus 820, and you can see that we consider the O of Y in positive direction of Y, but we find it negative, so we should change the direction. 520 pounds in this direction. Okay, we could find the answer, and the problem that we had was about some calculation about the last equation, and it happens, and we should check 2 or 3 times to prevent making mistakes. Okay, and the point about this problem was that this problem was a two-dimensional rigid body, and the point was that there was no need to consider free body diagram of beam. And another thing was about that for two-dimensional rigid body, we have three equilibrium equations, and that's it. Okay, have a good time and see you soon. Bye.